So with matrices, I'm going to get to this question in a moment, but I want to first just go over it because I'm not sure what you guys did in your algebra or algebra 2 class with this. When I used to teach algebra 2, before they kind of shuffled around the benchmarks for the network, we used to do a lot of work with matrices, but I haven't taught algebra 2 for about 4 years now, and they changed the benchmarks, so it might be a little different since I taught it. So I'm just going to make up some numbers here. And you don't need to write this down. I just want to talk to you real quick about a few things I'm going to use when I do my work with matrices that I hope that you know. If you do not know, I'm going to teach you right now. So the way you always want to think about with matrices is they always have dimensions, right? If you guys think about if you went to like your nearest Home Depot or Lowe's, you went to their like lumber section, there would be dimensions for all like the pieces of wood, right? A 4x4, a 6x5, things like that.
I went to Home Depot and I bought my first piece of wood.
And you'll never forget, right? It's the best. What a good one. All right, perfect to use in wrestling. Now, when you are doing dimensions, with matrices, it's always rows by columns. All right, rows. All right, rows by columns. If you're having trouble remembering which one is rows and which one is columns, think of like your most recent trip to Greece, right? Looking at the architecture in ancient Greece where they had all those columns, right? Columns are going up and down. Okay. Oh, I like it. Rowing a boat and you're going like this. I like it. I mean, you're not walking, but you get that. Okay. All right. Whatever works. So you know rows by columns. Now I put by the word, but you could also write an X for by. So if you notice today when I do the dimensions, I'll be using that symbol, that X, right? And Gladys already mentioned like when she bought her 2x4, I'm imagining that on the sticker or whatever, label for that, it didn't have BY, it probably had the letter X. All right, but that's my guess. Okay, so if you look at the one that I just made, all right, if you had to say what the dimensions were of this matrix that I just made up, what are the dimensions of this matrix? The dimensions. So dimensions is rows by columns. No. How many rows? 3 rows. How many columns? 2 columns. So this is a 3x2 matrix. These are just the numbers that are in the cells. All right, we're going to use those in a moment. But for now, I just want to make sure you know how to do dimensions. Okay, question. Whatever.
Are those just like random numbers?
Yeah, I made up the numbers. Now, the reason I need you to know the dimensions is because if you're going to add or subtract matrices, they have to have exactly the same dimensions, right? So if I were to write down, this plus, all right, do you see that next matrix that I wrote? You told me this was 3x2. What are the dimensions of this next matrix that I just made up? Rows by how many columns? 1 column. Are these dimensions, are they exactly the same? No. So if I asked you to add them together or subtract them together, could you do this? No, because they're not the same. So you would write here, not possible. Okay? Now, that's not going to happen today. All the ones you're going to do today, I'm pretty sure are possible. But I just want to make sure you know you're on the lookout, right? Because I could try to mess you up, that if I give you dimensions for these matrices that are not exactly the same, so the same rows and the same columns, you cannot add them, you cannot subtract them. Okay, everybody good? All right. Now, with that being said,
So you just put not possible.
correct. You just put not possible. All right, so let's look at this first one. The first one says to do A plus B. Okay, so the first thing I'm going to ask you is what are the dimensions for the first matrix, matrix A? 3x1. What are the dimensions for the second matrix?
3x1.
3x1. What do you notice about those rows and columns?
They're exactly the same.
So is this possible? Yes. And so all you're going to do, and I'm going to show you extra work here. You don't have to show this work going forward. I want to give you the best chance for success here. So I call this my work matrix, right? So I'm going to do -4 plus -3 in that first spot, then -2 plus 5, and then 1 plus 5. So hopefully your brain sees when you get a chance to look at this that I'm taking each piece that's in the same spot of those respective matrices and I'm adding them together. All right. So what is -4 plus -3? Okay. What is -2 plus 5? And lastly, 1 plus 5 is 6. Go ahead, Gladys. What's up? The ones that I put in parentheses are because they're negatives. I want to make sure you know that the negative goes with that number. Don't have to put the parentheses, but mathematically, mathematicians do put negatives in parentheses. Okay? But again, do you guys see the blue matrix? The blue matrix is not necessary, right? I'm just showing you what I'm doing in my head. Okay? I'm showing like extra work in this first one so we can practice. All right? So just remember when you're adding or subtracting, if they're in the same location of their matrices, then you're going to add them or subtract them, whatever operation it says. Everybody good? Yes. Right now, they mean nothing, right? They're just random numbers. But what happens later on, like in the real world, it might mean like this is for certain data from the class or from whatever you're studying. It's a way to organize your data. Yes, Natalia. Yes, they'll have spots. I'm pretty sure it'll do this, or it might ask you to say, hey, what are the dimensions of the matrix you want to put in for your answer? That's it. Yes, this right here is the answer. Just one. It's so I started off, I know, listen. Shh. I was not trying to make it more complicated. If you don't know this stuff beforehand, it makes it tough to do. Got to know the dimensions. Okay, let's do one more. All right, A minus B. So I'm going to do matrix A. Now, some of you might be wondering, Mr. Vendrick, do I need to write them down again if they're already listed? No, you don't have to. The reason I do is because what if this had said matrix B minus matrix A? I want to write them in the correct order because what happens when I teach this is students will think, oh, I got this, and they'll just do it mentally. And they'll get things wrong because the order does matter, especially with subtraction, right? So I would recommend writing down them again before you do the actual math. Yes, Joe.
Why is it like wonky?
Wonky. The numbers are wonky. Did I do something wrong?
Oh, I don't know. I thought that was like for a reason.
No, I mean, I'm not like the best artist.
That's not what I meant. Look at this space.
Are you talking about because some of them have negatives?
Yeah.
Yeah, so if they have negatives, then it obviously pushes it over a little bit because there's no negative there.
No, I thought it was for.
No, it's not like meant to be like weird. Okay. Are you ready for the dimensions? Okay. What are the dimensions of matrix A? 4 by 2 is right. 4 rows. 4 rows by 2 columns. 4 by 2 is right. Let's do matrix B. Let's do this one. Is that also 4 by 2? It is. No, I was talking to Gladys. Are they the same?
Yeah.
If they are the same, can I subtract them?
Yes.
Yes, you can. So I'm going to write down over here. Again, you don't have to show this work, but I like to. So I make sure I know what I'm doing in my head. Okay?
So it's all recorded now. Oh, no,
I'm sorry, Gladys. Go ahead.
no, wait, no, do it first now. Because
Okay. I got you. So the reason I do this is I want to kind of ask myself, how many answers am I going to have? Right? And if you look in a 4 by 2 matrix, how many different answers am I going to have?
20.
Not 20.
Sorry.
Okay, you got it.
8.
It's 8, right? You can also multiply. What's 4 times 2? Right? That'll give you 8. So I'm going to do 4 minus 2. That's the first one. The next one is 5 minus negative 2. This is where some mistakes might happen. Negative 5 minus 4. Negative 1 minus 1. 0 minus negative 1. Negative 3 minus 3. Negative 3 minus negative 1. And negative 4 minus 0. If you're having trouble, please let me know. This is a little bit tougher. There's a lot more numbers going on. I think subtraction will be a little bit more challenging. All right, so now I'm going to zoom in on my work matrix to draw my answer matrix. You don't have to put these little spaces. I just put them so that I know that I should have a number in each of these, but it's up to you. Okay, we ready? What is 4 minus 2? 2. And now I'm going to move through the first row, then the second row, then the third row, then the fourth row. Could you do the whole first column and then move to the second column? Yeah, it doesn't matter the order in which you do this. Okay, it's your choice. It does matter that I subtracted the stuff that's in the same spot. So, right, I subtracted 4 minus 2 right there in the same location of their matrix. So that does matter. But in terms of writing down the answers, I don't care the order in which you do it. What's 5 minus negative 2? It's actually going to be just 7. Oh, you were doing this one? No worries. I'm doing the first row first. But it's okay. Natalia, if you want to do the whole first column, that's fine. I don't care. Now I'm moving to the second row. Negative 5 minus 4. Negative 9. Negative 1 minus 1. Negative 2. 0 minus negative 1. It's actually positive 1, right? Because subtracting a negative is actually addition. Okay. Negative 3 minus 3. Negative 3 minus a negative 1. Negative 2. Right, remember this becomes adding. Negative 3 plus 1 is negative 2. And this one should be the easiest one. Negative 4 minus nothing is negative 4. So this right here is our answer matrix. And that is it.